Now we want to learn how to solve quadratic equations by completing the square. Now before we can really start doing that, we want to learn what completing the square is all about. Now we have what we call a perfect square with regards to quadratic expressions, and it can take the form x plus a squared, which when expanded will give x squared plus 2ax plus a squared. So what we have right here is a perfect square for quadratic expressions. Now if you look at our expanded form for our perfect square, you can see that 2a is the coefficient of x and a squared is the constant term. Now you can also see that there is a relationship between the coefficient of x and the constant term. Actually, the constant term is equal to half of the coefficient of x squared. What I mean is, if we take the coefficient of x, which is 2a, and we halve it, that is divided by 2, and then we square it, then what we're gonna get is a squared, which is our constant term. So that is the relationship between the coefficient of x and the constant term. The constant term is half of the coefficient of x then squared. So this is going to help us in answering some questions, like in this example the question is saying what must be added to x squared plus 6x to make it a perfect square. Alright, so with our x squared plus 6x, what has to be added to x squared plus 6x to make it a perfect square is a constant term, right? And that constant term is actually half of the coefficient of x squared. So how do we find that constant term? We are saying it's half of the coefficient of x squared. The coefficient of x is 6, and half of that squared is 6 over 2 squared, and that will give us 3 squared, which is equal to 9. So what has to be added to x squared plus 6x to make it a perfect square is 9. So that's simply how we can complete the square. That's how we can make a quadratic expression a perfect square, by adding the constant term, which in this case is half of the coefficient of x squared. Now if we want to write x squared plus 6x as a perfect square, having added the constant term, then it will be x squared plus 6x plus 9, but I'm just gonna write 9 as 3 squared so that it can come out in the form x squared plus 2ax plus a squared, and this will also come out as x plus 3 squared if we are writing it in the form x plus a squared, just as we had right here. Okay, so that is how it'll come out. It'll come out as x squared plus 6x plus 3 squared, and this will be equal to x plus 3 squared. Alright, let's look at one more example where we want to complete the square. The question is saying here, what must be added to x squared minus 5x to make it a perfect square? Now for x squared minus 5x, for it to become a perfect square, we have to add a constant term. And remember what we said? We said the constant term is half of the coefficient of x squared. The coefficient of x is -5, so half of that squared will give us 25 over 4. So what needs to be added to x squared minus 5x is actually 25 over 4, so that it becomes a perfect square. And if we are to express it now as a perfect square, in the it becomes x squared minus 5x plus 25 over 4, but I'm gonna write it as a squared. I'm gonna write it as negative 5 over 2 squared, so that it will come out as x minus 5 over 2 squared. So this is how it will come out if we are to write it in the form x plus a squared. It will come out like this. So what we are doing in these examples is exactly what we're going to be doing when we will be solving quadratic equations by completing the square. We're going to be completing the square in the same manner that we've been doing in this video.